Hello, I'm Anjana, and in this class of 5th generation, we will discuss 5G ear interface. And 5G name it as that it is my flexible ear interface. So we require to change our ear interface because of a high data rate and demands. So if this is network, a network is connected to mobile station, and this interface or user equipment, this interface will serve as ear interface. Now the ear interface, that means the ear interface of 5G is a unified ear interface which requires flexibility and adaptability. So I can say that it is my unified ear interface with flexibility and adaptability. So that's why from flexibility we name it as flexible ear interface. Now we require that my 5th generation ear interface should be unified in nature with flexibility and adaptability because to meet the 5G requirements. So why we require flexibility and adaptability? So that we can meet 5G requirements. So this is our demand that ear interface, whatever the ear interface I have, should require these things in it. Now it consists of, that means new ear interface, which is a flexible ear interface in 5G, should consist of various configuration mechanisms. So it consists of adaptive waveforms, as the very first is this should contains adaptive waveforms, then it should contains adaptive protocols, then it contains adaptive channel structures, adaptive coding, and adaptive multiple access schemes. So this is my requirement that as I want new ear interface in 5G because we have new requirements or we have high data rate requirements. So my ear interface should be flexible enough to meet all those requirements. And in order to meet all those requirements, like we have require adaptive waveforms in our systems, protocols, new channel structures, we require new coding techniques and multiple access schemes. That means we require block and configuration mechanisms in it. So what we require? Block and configuration mechanisms to support all of these entities. As we have studied about ear interface of 2G and 3G as well as 4G cellular system, so we have like OFDMA, SCFDMA, carrier concept in ear interface because each and every data or the packet is to be held by ear interface. That's why we require new waveforms, protocols, channel structures so that we can meet the desired requirements of 4G. 5G. Now I will draw a AR interface like this is my 5G air interface. So I will write 5G air interface. Now here at this end I require mobile internet. So I am drawing here mobile internet. Now what is the demand of mobile internet here at this end? Internet demand is universal radio, or I can see we are demanding for ultra high data rate. So this is my demand here at this end. Now at another end we have connected cars, or I can say Internet of Things. So all are connected with this air interface. Now we need to add on some entities here in this part so that it can provide ultra high data rate or universal radio concept, and this should be able to meet the requirements of connected cars or Internet of Things. Now what is there in this part, which is my 5G air interface? Like we have SCMA concept. After that we have massive MIMO in air interface. SCMA, this one I will write here. SCMA stands for Sparse Code Multiple Access. SCMA, we have a massive MIMO. We require full duplex mode. So after full duplex mode, we require flexible waveform. Flexible waveform concept. Then we require polar codes. So flexible waveform polar code, we require spatial multiplexing concept. So we have a concept of spatial multiplexing, flexible waveform, massive MIMO, SCFDMA. Now this flexible waveform is my FOFDM. So I will write FOFDM, which is my flexible waveform, where F is flexible orthogonal frequency division multiple access. So as we have discussed the requirements of this part, that we require flexible waveforms, OFDM, that we require codes, we require multiplexing techniques, and we require multiple access technique also. And my mode should be full duplex mode with the MIMO concept. Now why I use MIMO, that means massive MIMO. Massive MIMO is a concept in which we have multiple input and multiple output. So in 4G, we are using 4x4 or 8. In 4x4, now we are using above that. That means over 4x4, we will use the massive MIMO concept, and we have number of inputs and number of output devices connected to one another. Now, as my requirement is IoT or high data rate at both ends, so these are the things that will work in this part, which is the air interface. That then and only then it will be possible to achieve the 5G requirements. Like starting with the very first, Sparse Code Multiple Access. Now it is one of the multiple access technique that will increase the speed. Then we have MIMO concept, that means at the end we are increasing the number of antennas. Now full duplex mode, flexible waveform concept, polar codes and spatial multiplexing. Now we will discuss each and every entity in this air interface in detail. Like why we require this air interface. So we have studied that air interface should be flexible. So we require that this interface should be highly flexible. So this became the requirement of this interface, that this should be highly flexible and its efficiency, that means it should have 3 times spectrum efficiency. So 3 times spectrum efficiency. So as my aim of 5th generation, that I require my spectrum should be efficient as well as energy should be efficient. So what we are making, that as this air interface is flexible in nature, but I require to increase the efficiency of the spectrum almost 3 times comparative to that of the previous generations. 3 times I require more flexible air interface or spectrum efficient air interface. Now the key components of this interface. So I will write key components. So the key components of this interface is FOFDM. Now flexible, or it could be the filtered. It also named as filtered OFDM. Now I have used the concept as a filtered because filter is related again than flexible. Now filtered orthogonal frequency division multiple access, and then we have SCMA, which is sparse code multiple access. So both of these, that means FOFDMA and sparse code multiple access, will help to reduce latency. Now my aim or my goal of 5G is to have latency less than 1 millisecond. So these two key components is helping me to achieve a latency which is a reduced latency. Because reduced latency will work in services which are bandwidth, which are my bandwidth consuming. So bandwidth consuming services, these will help, key components will help to reduce latency, because we have a bandwidth consuming services like we have virtual reality. So like virtual reality is the service which is bandwidth consuming, and it will help to reduce latency, both of these key components in my systems. So key components are filtered OFDM, and next one is sparse code multiple access. Now let's study FOFDM. So we have a concept of filtered OFDM. Now this is my fundamental waveform. In the previous session, I have written here a flexible waveform. Then I related to FOFDMA, flexible OFDMA, which is my filtered OFDMA. That's why flexible waveform. Now, it is a fundamental waveform technology to support different waveforms. So, I will say that this is my fundamental waveform technology to support different waveforms. So we have orthogonal frequency division multiple access. The term as multiple access here, that means it will going to support different waveforms in a single unit. So that's why this one will become a fundamental waveform because it is combining number of waveforms together. Now multiple access scheme and the frame structure. Requirement of multiple access scheme and channel structure is as per the service requirements. So we will use multiple access scheme as well as different channel structure, and this is as per the service requirement or application requirements. So this is totally based on the choose of multiple access scheme which we are going to use, as well as the channel structure is dependent on what type of application and what type of service requirement do we have. Now, in fundamental waveform technology or in OFDM, there is a coexistence of different waveforms. That means with different OFDM parameters, different waveforms will coexist together. Like, I will show an example. Like these are the different three waveforms. And suppose that these are having OFDM parameters of their own. That means each and every waveform having their own parameters. So they are having their own parameters. Now there is a coexistence. That means we are going to show these existly, combinely one another. So I will mark here this waveform as a green one. So we are coexisting this one with the black one, and then I will mark here a red, and this will coexist together. So what is there in this filter? Like three waveforms, I am having three waveforms as black, green and red. So these three different waveforms are combining together. So I have a coexistence of waveforms with their own parameters in a single unit, which is a filtered OFDMA concept. So I will explain this with the help of one example. So like I have three subband filters. I require three subband filters. What we require three subband filters which are used to create three subcarrier three subband filters which are used to create three OFDMA subcarrier grouping. Now, so we have three OFDMA subcarriers. Again, black, red and green one. So I have 3 subcarrier OFDMA. Now we require 3 subband filters. So why we require? In order to group them together. So in order to group them together, we require 3 subband filters. Now all of these will have proper spacing. So they will have proper spacing in between. So that why we have proper spacing in between, so that will not interfere with one another. And also they have proper durations and guard times. So filters will be provided with their suitable spacing, their suitable durations, as well as their guard times, so that all of these subcarriers of OFDM will not combine or mix up with one another. Like I have here a frequency and a time axis, and I will show here 3 blocks. Okay, now if I see the waveform concept, and waveform concept again in the frequency and in the time axis with their spacing. So I am grouping together their amplitude may change, their amplitude may vary, like so this is my filtered OFDM. So we require to provide guard time and guard intervals in this concept of multiple access. So why we are having a multiple access? Because we are combining number of waveforms together. So this is spacing 1, single carrier 1, this is 2, and so on up to the number of. So this is a concept of filtered OFDM that we have discussed in the air interface class today. We will continue with next in our next classes. Thank you so much.